Hi, everybody. My name is Mariano. I'm the head of engineering of cLabs, but I guess 2 weeks ago, I was also the head of the blockchain team. And so I'm actually going to talk about the blockchain and Celo 2.0, or I guess try to speak a bit more about how we are getting there or what we've been doing so far. So I've been told that you always need to start with a good cartoon. That's a joke. I guess you all know Dilver, or I guess so you should, if you come from tech. And I also hope it's not going to be a boring presentation, but we'll see. So first, let's chat about what's our scalability strategy. So how do we think about scalability? First thing that we think is don't over-engineer. So I guess everyone is an engineer usually makes the same mistake. We are scared to over-engineer. We always want to create the best solution ever. And when you are building a product, that's not probably what you want to do. You want to do something that you are accompanying the product and you are trying to make things better, but at the same time not try to create a rocket science when you don't need that. I would say that's especially important in crypto because if you've seen crypto advance very, very fast, and if you were, let's say 2 or 3 years ago trying to think the best blockchain solution ever, and you try to think that now, it could be a totally different thing. So why try to do that very, very early in the game if you can try to do it alone? So I guess that's kind of our strategy, and so we are trying to always be ahead of the demand. So for the demand that we have, we want to have a solution that is much better, but not entirely like a rocket science at that point, so we can always improve. So one of the first things that you can do when you are trying to scale, it's talk about how can you increase the block size. So I guess everybody here knows that a blockchain has blocks. So you mint or validate blocks every couple of seconds. In case of Celo, 5 seconds. So if you want to be able to process more transactions, what about bigger blocks? Again, that's not that easy, right? You need to be able to process the whole block in that matter of seconds. But if you've been following or if you are more on the all-one kind of development, you will probably have heard that, hey, but that's not a bad thing. And you could, if you've read about it, what you will see is that they say, okay, yes, because that can be bad, because if you have really, really big blocks, then not everybody would be able to process that. Not every computer out there in the world. And when they speak about decentralization, what they are actually saying or thinking is okay, I want to have a blockchain so that everybody can run a node on their laptop machine using only, let's say, 10% of the whole resources, 10% of internet, processor, everything, And so why do you want to do that? Well, because the idea is if you got that, then it's not only the elites, that would be validators, exchanges, or other powerful players in the ecosystem that can pay for a node. They are going to be basically verifying the network, and that's kind of a way to control those elites. Now, I guess that's nice, but I would ask anyone here, do you run a node? So I think to me, the problem there is people usually don't really want to run their own nodes. They want to, I guess if you are that developers, you're probably using Forno, you're probably using Figment or any other node provider, and you're trying to delegate that responsibility somewhere else. So if you can try to achieve the same goal, but with other means. You still want decentralization, you still want to control the elites, but maybe it's not about getting everybody to run their own nodes, or at least not a full node. So something that you also want to address is knowing that, hey, we actually have different kind of nodes in the system, So why would we expect that they are all basically the same? We have validators. So validators are incentivized by the network. And so we can ask them to actually run more powerful computers. Full nodes, well, DApp applications, you can run your own server, you can run your own full node. But basically, we are thinking that these are like, let's say, entry-level servers, things that are not big computers, small computers, but that everybody more or less can run those. And finally, you have light nodes, where we are aiming there, like everybody should be able to run a light node on their own smartphone. So as you can see, there are like different levels of nodes, and you can imagine that there's different levels of requirements that you're going to ask to them. If you think like that, you are able to, I guess, have a different sense of how you are going to do block increases. Finally, Celo also has this idea is like you can actually incentivize full nodes. So if you incentivize full nodes because they are providing a service to the clients, then it's much easier to ask them to actually run on better hardware, right? So let's talk about block size increases since mainnet. First, we launched with a 10 million gas block. And maybe I'll go a bit before that. No? So when we talk about block sizes, like any transaction out there, basically you can measure it in terms of gas, how much gas this transaction cost. And so what we are saying is like if I have 10 million blocks, that's a number of transactions that I can get into a block every 5 seconds. Last year, we went to 20 million gas, so we double. And now we are going to 35 million gas. Again, that's not something that just changing a configuration and it's done. I actually need to put a lot of work into it because, again, you need to be able to process all those transactions that fit on those blocks in that time. So we are currently have like a governance proposal that you can find out there about the test and how we are thinking of moving to 35 million. Actually, we could actually move to 50 million, but I guess we are planning to being cautious there. There's a very nice change that we on Expresso. It's called block context, where basically we are improving the whole way on how we process transactions that are actually one of the main things that it's actually allowing us to do this increase right now. So those are basically the numbers. So we've been like a 250% increase since mainnet and a 75% since last year. That's what we are getting at right now. So now my idea is to speak a bit more about like Celo 2.0. What are we thinking in terms of that? So this is brand new, and this is more of like, a glimpse. So first thing that you need to understand when you think on a blockchain, no? I don't know how many of you are like L1 developers here. Cool. Okay, we have a few. So first thing you need to understand is that blockchains are just databases, distributed databases. What do I mean by that? No? So when you have a database, you need to control how do you write into a database. And when you have a distributed database, you have like what you call primary nodes, that those are the nodes that are actually where you write, no? And so in a blockchain, those like all the validators are primary nodes. And all the full nodes, you can say, are replica nodes or read nodes, where you can all go there and read. So you have like kind of a huge problem, which is, okay, how do I make all these primary nodes work together? And basically, when you are processing transactions or trying to write operations, what you are going to do is, hey, I first need to order transactions. I need to first like agree on what are the transactions I'm going to be getting in the blockchain, and then I need to execute them. And actually, because there are many primary nodes and it's decentralized, I also need to agree that we are executing them in the same way. That's what I would call like the apply function, no? So how you apply a block. So if you got this insight, now what could you do? You could basically try to split responsibilities. You can say, okay, what if I order them first and execute them later, right? So what if I have a subsystem that is very, very, very good at sequencing and ordering transactions, and then I have another subsystem that is very, very good at executing transactions. In that way, by splitting responsibilities, what you are basically doing is splitting the job, which allows you to go faster, right? Like one of the key things of like scaling anything, it's try to be or splitting or being able to horizontally increase, so like have many entities doing the same thing. So that's what narwhals come into place. I'm not going to speak too much about narwhal because coming next, there's a chat especially about narwhal. But narwhal, it's this distributed system that is basically providing a mempool for Celo, no? And it's going to do that very, very fast, so it's able to sequence transactions. And by sequence, I mean like order transactions, no? Very, very fast at like more than 100,000 transactions per second, and actually can be increased and can actually scale horizontally, no? So with Narwhal, now you have this solution that it allows you to already agree beforehand what's the order of transactions that we're going to execute. No? So that's kind of solving half of the problem. Then you need to solve like the other half. So it's more about how do you actually scale the other part, which is execution, which I would say it's like quite a bottleneck, right? So let's think about that for a second. No? So first of all, we need to be able to parallelize execution. You need to be able to process transactions in parallel. No? If you do those in sequence, then the only way to scale is to actually try very, very, very big machines, which is not really going to work. There's probably like a different insight that you can say. It's like, hey, there are actually different applications. We use the blockchain for different things. Let's say, hey, we are doing a lot of payments. So can we do like very, very good at payments if we already know that payments is going to be like a big thing for us? Yes, we can. No? So can we try to have some like more specialized use cases? Because we already know from day one that those are actually important. So building a specific solution for payments seems like a good idea, especially for Celo. Another thing that you might think is that state and history also need to be decentralized. One of the big problems that you have is that if you want to say, hey, I want to build a blockchain that is going to be the computational space for everything in the world, and I'm going to want to fit that in a single computer, well, I guess you have a problem, right? And so you will need to have something that you need to distribute state, basically have states and history distributed in different machines. And I guess maybe I should clarify, history is the history of all the transactions that came into the blockchain. States, it's the result of applying those transactions. And finally, this is what they call verifier dilemma, and this goes to decentralization and the elites again. So when you are trying to build a decentralized system, one of the things you want to do is like, hey, I don't want this to be controlled by the elites. So I want to make verification cheap. I want to be able to, for anyone to verify the chain. But we should also try to make things easy to verify, but that shouldn't be a constraint on how fast or how much of our requirements are going to ask for execution. Because if we're going to ask validators to go on like cheap software, cheap hardware, because we needed it to be cheap for verify, well, I guess we kind of have a problem in how we're going to design things. So this is how we are thinking about it, and this is kind of like more of a proposed design, no? Again, it's much out there, and we are still figuring out a lot of the details, no? So first of all, the idea is to have a single mempool. So we have Narwhal, this massive mempool that can sequence very, very fast. And so we want to use that as a single point for every transaction out there. So every transaction should go through Narwhal. And then the idea is that we had to have multiple execution environments. So we want to have, again, as I said, like there's different things that I want to do on a blockchain. So maybe you want to have an EVM chain, you want to have a move chain, you want to have something that is specific for payments. No? So you want to try to have all those things. But that doesn't mean that you need to have like many chains all like on their own subworld, you can also have them all within the same consensus engine. So the same set of validators are actually going to be validating the whole thing. No? So you are going to have like these multiple execution environments where you're going to agree on consensus on all of them at the same time. And again, as I said before, because it's Celo and because payments is super important for us, you also want to have something that is specific for payments. And again, the last thing is that you also need some kind of like these execution environments to communicate. So you will need some kind of bridging technology that connects them all. Now, so this is more of a picture of how you could imagine this. So you can imagine that you have the narwhal memcall that it's basically feeding transactions to the system. Then you can imagine that you have like this idea of a block, but then this block has, let's say, like sub-blocks. No? You can have like a block that is basically every sub-block is going to be like it's the history and the results of this execution environment. And so you're going to have one that probably is the EVM, so we are going to still run the EVM, and you're going to be able to do all that you want on the EVM. We can also have another one that it's basically for payments, so you can process and do a lot of payments very, very fast without needing to go to the EVM for that. And you can also have like others that run on move. No? And again, the idea is that you can have as many as you want, and you could actually try to create others that are more specific for different things. And behind all that, you would also need this kind of a bridging technology, so you can basically pass information from one to the other. And I said it's a sync bridge because you have the advantage here that because they are all ticking at the same time, that that it's easier to communicate them, which is different than what you would do on like any other bridge, because when you are doing a bridge, it's basically a sync. There are something that it's ticking on its own on its own tempo, and this is a ticking on this other tempo, and then you need to create like some decentralized protocol for them to communicate. So then maybe let me chat briefly about this thing that I call the verifier's dilemma. So the whole idea here is like, hey, having something that it's cheap to verify shouldn't mean that it needs to be cheap to construct. Because if I do that, if I put that into my design, then validators and block creators need to be also running like on cheap software, no? And that's to me like I don't know, like you are putting like a big limitation on what you can do. So I guess there's many ways you can try to do better. One thing, for example, that we've seen on this paper from Flow, it's, hey, I could actually try to split the verification problem into many parts. So if you imagine that a block is a transition from like before that block and after that block that actually computes a lot of transactions, I could, for example, try to split that into smaller transitions and then have smaller machines verify each of those transitions. No? So then I would basically be splitting a problem into a lot of small problems that those are easily to verify. And so you could still try to achieve that same level of verifiers, that decentralization, without needing verifiers to verify the whole thing. I'm basically crowdsourcing the verifying. No? You could use zero-knowledge proof. Shards, it's another idea of the whole thing. No? The idea is like, okay, you only verify a shard instead of verifying the whole thing. So those are basically, the concept is similar. No? You are trying to create something that then it's easier to verify. So that's what we can do on verifier's dilemma. And I guess there's much more that we need to do here. Something that it's actually very important is like talk about private transactions. Imagine you are somewhere in Argentina, you want to pay for a coffee, you go there, you pay, and then the person that sold your coffee actually can see your balance and know how much money do you have, and say, hey, let's rob this guy. So I guess the idea is like you should create something that allows you to be private or have something in the middle that allows that like not everybody be knowing what's your balance on your bank account. That seems kind of dangerous, right? we also need to, and I'm out of time, but I guess you also need to work on like the better Flask like client. You've seen Plumo. There's a lot of work that we need to do there, a lot more that we want to do on full node incentives, and also a very cool thing that is rollups. That's also part of the scaling strategy, and so it's a question of how we make those native. Again, you can join us in a conversation. We can find us in Discord and Celo forum. I think this is more of like for all of us to share and discuss, and I'm happy to have you there. Thanks.